Hello, everybody. Today, we are going to talk about the HR diagram. So the last couple of days in class, we have been doing the HR diagram stations, where we have been learning and exploring about the HR diagram and kind of how to read it. Today, I'm just going to go through the HR diagram that we will find on page 15 of our Earth Science reference table. And we will explore the specific HR diagram that we have on this table. Okay, this diagram is going to be a little bit different than the one you have been looking at during your station exploration, but this is the one that we are going to be looking at most of the time throughout this year. So there's a lot of information to take in on this HR diagram. So we're just going to start very basic, very simple on what the HR diagram tells us. The HR diagram at its core tells us these four things about a star. When you plot a star on the HR diagram, we are determining, we are finding out, we are telling somebody about four characteristics. And the four key characteristics that an HR diagram is telling somebody is the temperature of the star, the color of the star, the luminosity or brightness of the star, and the size of the star. An HR diagram only tells you those four things. It does not tell you anything more. It does not tell you anything less. It tells you exactly these four things. And when we're studying stars, these are really the most important things anyway. As we are going through this video today, I do expect you to be taking notes. So let's begin, of course, by taking notes about these characteristics. If at any point you find that I'm moving too fast for you to take notes, this is a video, you can pause this video. Okay, so let us continue. So these are the four characteristics of a star. Now, how do we find these four characteristics on the HR diagram? Like I said, there's a lot of information here on the HR diagram. So we will just continue by looking here at the HR diagram. We are going to start with the x-axis, as you usually should do when you're looking at a graph. The x-axis has two different pieces of information here. The first piece of information is our surface temperature, the surface temperature right here. And the values above where it says surface temperature are going to tell you the temperature of the star in something called Kelvin. Kelvin's very similar to Celsius. It's just off by like 200. You don't really need to worry so much about what Kelvin is. What you do need to understand is that 30,000 Kelvin is incredibly hot. Even 2,000 Kelvin would be enough to melt the Earth. And that is a cold star over here. The sun is right about right here on our diagram. So the temperature of our sun ends up being about maybe 5,500 degrees Kelvin. Okay, so on the x-axis, we have surface temperature in Kelvin. One thing to notice here about our surface temperature is that our largest values are over here on the left. We have 30,000 over here on the left. And as we go towards the right, our value is actually decreasing. It's getting smaller as we go to the right until we end up at about 2,000. What you should notice here is that this scale is backwards. Why is this scale backwards? I don't actually know the answer to that question. The two gentlemen who developed the HR diagram decided to make it backwards. So on the x-axis, we have surface temperature. We also have color. So our color will also be here on our HR diagram. Once we start looking at the HR diagram, we're going to notice that we usually think of red as being a temperature associated with hot and heat. But here on the HR diagram, a red star is actually a cold star compared to the other stars. It is a cold star. And a blue star, a color that we usually associate with winter and cold, is actually the color of the hottest stars. So if you're looking through a telescope and you see a star that is blue, that star is actually incredibly hot compared to a star that is red. So let's look back up at our HR diagram. And again, over here, we can see our surface temperature and we can see the color. And we can clearly identify that at around 2,000 to 3,000 degrees, our stars are red. And as we get warmer and warmer and warmer, up to 20,000, 30,000 degrees, our stars are going to end up being blue. And then we have the colors in between. So from red, we go to yellow. Sorry, we go to orange, yellow, white, a bluish white, and then blue. Again, if we were to look at the sun here. So again, here is our sun. We go straight down to find our temperature. Like I said, was about 5,500. And we continue down and we discover that the color of our sun is yellow. And we know this to be true. We've all seen the sun. The sun is absolutely a yellow star. So that is our x-axis. Along our x-axis, we have temperature and we have color. The y-axis, a little bit different. On the y-axis, we have two other characteristics. On the y-axis, we have something called the luminosity. Luminosity comes from the same root as illuminate. When you illuminate something, you are lightening it up. When you are illuminating something, you are brightening it up. So here, our luminosity, we start with very, very small luminosities here, 0.0001. And as we go up, we end up going all the way to the top of this graph at 1 million luminosity. Okay, and that is over here on the left side. If we find the sun, which is located right here, and we go over, we find that the sun has a luminosity of 1. What that is telling us is that the sun is our reference for the brightness of all other stars in the universe. We gave the sun a luminosity of 1 because that made it easier for us to compare it to the other stars across our galaxy. So we have our luminosity over here, which increases from small up to large, as graphs usually do. And over here on the right side of our graph, we have a second y-axis. And our second y-axis is the size of the star. And that will be over here on the right-hand side. So the size of our star, we start with small down here. So these stars are going to be small stars. They're going to be smaller in size than most. And as we go up this y-axis here, our stars get larger and larger until we have about medium stars, and then larger and larger until we have something called massive stars. So massive means large. Massive means absolutely huge. So on this y-axis, we start at small stars and we continue going up until we get to large stars. You'll notice there's no numbers over here. It's all just kind of a relative scale. So what you might have noticed is this right here, that as a star gets more massive, its luminosity or its brightness increases. What this tells us is that the brightness of a star is dependent on the size of the star. It's not actually dependent on the temperature like you would think. It doesn't matter how hot or cold a star is. What matters is the size of the star. The bigger the star is, the brighter the star will be. Okay, this is all I have about the HR diagram and the characteristics of stars. What you're going to continue with today are going to be some practice questions using the HR diagram here. So as you begin your practice questions, make sure you have your Earth Science reference table open to page 15. Once you open it up to page 15, you will see this diagram here, and you can use this diagram to answer the questions about the characteristics of stars. I hope you have a great day, and I'll see you next week.